Now, in cases when we have a variable density, that is when density is not constant and varies, so in that case we need to find its dependence on pressure or altitude, and this is in the category of standard atmosphere, that we will utilize an equation that will relate pressure and density, and it is the equation of state that we will use to do that. Now from equation of the state for a perfect gas, I can write down equation P equal to rho RT. From this equation I can get the value of rho, and we'll substitute this value of rho density into the differential form of hydrostatic equation that we derived earlier. So once I substitute that value here, I will go and get this equation 1, which I will certainly perform the integration to find the value of P. But here I have to consider the dependence of my temperature on the altitude also, because this dy is the altitude, so this T is a function of y, so I have to introduce a function of T, temperature, such that I can perform the integration, which I will do next. Now after eliminating the density from the equation, a new property named temperature T has been introduced in equation 1, and we need to find the dependence of this T with altitude. As all of you know that when we talk about the temperature, we show that the temperature varies with respect to the height. Now this is the stage in the derivation of this equation where standard atmosphere comes in, because he will going to go and utilize the natural property, the variation of temperature with respect to height, altitude. As all of you know that it has been experimentally determined that the temperature varies, means reduces almost linearly from sea level to 36,000 feet of height. The standard temperature region variation has been categorized into 3 regions. So the first region is commonly known as troposphere. If you remember that kind of curve that we have drawn, so that is the 36,000 feet height, and on this height temperature varies linearly. So we will going to go and consider this variation. Since temperature varies linearly, so this means that the slope we can easily determine and write it like that for this region number 1, and I am calling this a constant name beta, which is called the lapse rate. Make sure that this equation, this relationship will exist for the range of h that varies from 0 to 36,000 feet for region 1, called troposphere. Now equation 1 can be written in this form, in which dy has been replaced by this dh, and from the previous equation that we have developed for the troposphere region, the dt can be equal to this, and upon integrating this equation you will get this equation of a straight line, which is nothing but simple is, if you remember that in your troposphere region the temperature varies linearly. T0 is the temperature at the sea level, and this is your dh and dt. So slope intercept form equation has resulted in this equation of a straight line. Now subsequently, from this equation the value of t will be substituted in this equation 2, if I call it, and this will result in, we will get this equation, and To get the value of P, we have to perform the integration of this equation. So integrating the limit at sea level, if I call the pressure at P naught, sea level means 0 altitude, and I'm going for an arbitrary value, let's call it H height, and the corresponding pressure will be P. So upon integrating this equation, I will get this equation in which I will go and substitute these limits. So after performing all these simplification, and at the end I will get this equation, which is my equation that will predict the pressure, and by considering the variation of temperature versus height. So in this equation, make sure that beta is called the lapse rate. Okay, lapse rate. Now, for standard temperature and pressure at sea level, the value of beta will be 3.5662 order of minus 3 degree Rankine per feet in the FPS system, and in matrix system it will be minus 6.5 order of minus 3 degree Celsius per meter. Also, the pressure at the sea level in FPS system is 2166 pounds per feet square, and the temperature is 59 degree Fahrenheit or 519 degree Rankine.